Carbon dioxide or CO2 is one of the most abundant greenhouse gases or GHG emitted by human activities. Increasing amounts of GHG in the atmosphere can lead to a significant increase in global temperatures and sea level. Additionally, CO2 is an asphyxiant and a toxicant. It can cause mild to lethal effects to humans depending on the concentration and amount of time and exposure. Therefore, it is important to monitor CO2 levels in the atmosphere and enclosed spaces. One method of CO2 gas sensing is the nondispersive infrared spectroscopy or NDIR. Unlike the traditional dispersive infrared spectroscopy, NDIR does not use dispersive elements such as diffraction gratings or monochromators. Instead, it is made up of an IR light source, a gas chamber, and a detector with an optical filter coinciding with the absorption wavelength of the target gas. NDIR gas sensing is an absorption-based method that depends on the Beer-Lambert law. However, gases do not absorb all the light passing through the sample cell unlike solids and liquids. Hence, a modified Beer-Lambert's law is necessary for compensation. The optical path length is an important parameter which must be considered in the design of an NDIR CO2 sensor. We were able to develop a modular CO2 detector using a thermopile-based NDIR technique. It features interchangeable gas tubes, short and long, to allow adjustments in the optical path length. The results show that the short tube setup allows for higher detection limit but with lower resolution. On the other hand, the long tube setup highlights a greater resolution but with lower detection limits. Additionally, it was found that the modified Beer-Lambert's law better represents the empirical data compared to the unmodified one. The developed NDIR gas sensor is accurate for CO2 concentrations from 0 to 2,800 parts per million or ppm with an uncertainty of 18% for the short tube setup. Meanwhile, the long tube setup is accurate from 0 to 1620 ppm with an uncertainty of 15%. The ability of the interchangeable main gas tubes to adjust the optical path length proved to be a significant component in determining the responsivity and detection limits of the setup. Therefore, the modular NDIR CO2 gas detector demonstrated the possible changing of responsivity and detection limits in accordance to the intended application.